how the microprocessor with the memory and also with the devices or peripherals. So they are connected with each other by using the address bus, okay, and also using the control bus and also the data bus. Okay, so as I said last Tuesday, the address bus is used for determine the location, right? So for example, inside the memory, there are many locations that are available. For example, we have, let's say we have the capacity of the memory is 16 bit, okay? So for 16 bit, so we have how many locations are available on the memory? Who can tell? So if we have 16 bit, right? If we have 16 bit system, so how many memories, how many locations can be stored, right? How many locations can be stored on the memory? How many locations can be used? So who can tell me that? Any one of you? Nah, semua dah lupa ni. So how many locations?
16 kan?
So 16 bit, how many locations?
65536.
Yes, that's good. Right? So you got it correct. So it's 2 bit, it's 16 bit system. So you obtain 2 to the power 16. So which you obtain 65536 locations available. Okay, for you to store the data and also instruction for the microprocessor to work. Okay, so let's go back to slides a little bit. Okay, so let's looks back here. All right, so basically we have this instruction. This one. Okay, we have this action. All right, and this code, all right, this instruction. So these instructions are stored in the memory. Okay, and this one is also stored in the memory. Okay, so what we have, first, this is the microprocessor. Okay, so this address bus, so it will be connected to the memory. Okay, this control bus will also be connected to the memory, and also the data bus will be connected to the memory. Okay. Okay, so you want to perform this program. Okay, so whenever the microprocessor will first send on the address bus, So to find B0, okay, B0 on the memory, okay. So you need to fetch the information of B0 from the memory. So while searching, so the memory will help the microprocessor to find that inside within its location. So it found that it is at location of 1400. Okay. So note here, H is for hex. Okay. H is for hex. So the number is in the base 16. Right. So you have the memory address is from 000 until F F F F. Okay. So that's for the 16-bit configuration of the memory. Okay, so 16-bit is equivalent to hex. So in the hex, so we can name that as starting from 000 up to FFFF. Okay, so once it found, now it already found. So code B0, and then it needs to bring that B0. We now found a B0. Bring that B0 to the register. Okay, let's say here register A. Okay, once it brings to the register, because register is like a temporary storage. Okay, it is a temporary storage inside the microprocessor. Okay, so that's the function of the register. Okay, so what we need to do next? Okay, now it has the instruction. So this instruction needs to be decoded, and then the data is bring to this location. Okay, it is brought to this location, and then the instruction decoder is used to decode what is meant by B0. So what is meant by B0 over here is to move a value to register A. Okay, and then once it got the message, then the control bus will function. Okay, then the control bus will go back to the memory to find out what to be moved. All right, to find out what to be moved. Okay, so what need to be moved is at the memory location of 1401. Okay, 1401. Okay, so whenever the control bus start working, so this it will also connect with the address bus to search for the next action to be done. So the program counter will increase. Okay, now it will increase by 1. Okay, so it will become 1401. So it will look for the information at 1401. So what's the code on the memory? So the code is 21. Okay, so 1 will be brought to register A because we need to move that 21. Okay, now the 21 will be on register A. And then what's next? So once it's done, so the program counter will increase. Okay, more. So it will be 1410. Okay, it will be 1410. So once it becomes 1410, and then what's to be instructed? Okay, so it to find out the 04 code. Okay, 04 is for addition a value. Alright, so it will ask, okay, then you put the 04 code on the address bus. Microprocessor put 04 code on the address bus, and then this will go to the memory, and then memory need to find, okay, where is 04 in my body. Alright, so it is at 0410, for example. Okay, 1410. Okay, so 1410. So now it is found. Okay, now the 104 code can be brought back on the highway, on the address bus, to the shift register. Okay, to the shift register A. Okay, so once that is done, okay, we need first to decode. All right, first to decode. Then it goes to decode and then check what's that code 04 means. So the code 04 means for addition. Okay, so it's for addition. So addition, then after that, the control bus will work. Okay, to find that what value to be sent. Okay, the value is found on the memory and then transferred to the data bus. Okay, transferred to the data bus and then bring to the register A. But it's not finished there because it needs to perform the addition. So the value of 21 with, what value is that? 42. Okay, gets this value 42. So the counter will keep increasing. Okay, the counter will keep increasing in sequence. Right, the next value is 42. And it will be brought to this ALU. Okay, so 21 will be added with 42. Okay, once it is computed, and then the sum will be stored again in the register A. Okay, and then it is not finished yet. So it is not finished. Then the counter will increase. The counter will increase. So the similar process will follow. So the microprocessor needs to put the code of 04 because it is the same one. All right, it's the same one. But here, the memory doesn't need to search again because it already searched for 04. So it was the previous step. So it just So it knows already that is addition. So directly the control bus will work. All right, the control bus will work without having to do the decoding function because the code is already decoded, and then we'll find the value of next value. What is that? That is 12. Okay, so that is 12. So this value of 12 will be brought to register A. Okay, so it will be brought to register A over here, and then the next step is to do the addition, right? To do the addition. So these two values, the summation of this and this value will be brought to the ALU, and ALU will do the computation. Okay, and later we'll store here. Okay, and then the counter will increase after that. And next, okay, the program, later it found that the code is from the memory is to halt the program, to stop the program, okay, to suspend the program. So after it found, and then the instruction instruction decoder decode, all right, so it will just stop there because there's no data need to be transferred anymore. So remember that for the address bus, we decode for the instruction given to the microprocessor. Okay, but for the data is the value itself. So the value is taken from the memory to be sent to the microprocessor. Okay, so I hope you can distinguish the difference between the functions of um, the instruction register, the program counter, and also the address bus, control bus, and also for the data bus. And also for the computation, you know that ALU is the main component to do the computation. ALU stands for Arithmetic Logic Unit. Okay, so I hope it is clear on how the microprocessor works. Okay, all right. So we will continue next. All right. So last Tuesday we stopped at the history of the microprocessor. So we stopped until 8086. So we will continue further with that. Okay. All right. So last time we learned about the history of microprocessor, the Intel microprocessor from 8008 until 8086. Okay. So now we move further. So we have the history of 8086 up to the Pentium Pro. Okay. So might be you can still find the microprocessor of Pentium Pro right now, okay? Because it was introduced in 1965, okay? So the Pentium Pro, and then you have the, I don't remember what's next after the Pentium Pro. You have maybe the Pentium 2, Pentium 3, something like that, okay? And then you also have the Pentium 4, if I'm not mistaken. All right, and then you enter the era of Intel Core, all right, and then dual core and so on, right? Until now we have the i3, i5, 7, and latest we have i9, all right? So that's the evolution of the Intel microprocessor. So we look at the difference of the technology. So starting from the 8386, so it is used the CMOS technology. Okay, and starting from Pentium, the BICMOS is used. Okay, the BICMOS technology is used. So as you can see that the clock rate is double. Okay, it's double from CMOS to BICMOS. Okay, and then again it is more than double. So more than double is about 2.5 times the clock rate for the Pentium Pro. Okay, and then tremendously the number of pins also increase. Okay, and then the number of transistors used also increase. Okay, and then for the physical memory, okay, for the Pentium Pro, it can be utilized up to 64 gig. All right, and then for the virtual memory, it can utilize up to 64 tera. Okay, and for the internal bus, so it is still 32. Okay, and then we have the external data bus up to 64, and the address bus. Okay, you can see the highway is now made bigger. All right, so it can support up to 36 bit. Okay, it can support up to 36 bit, meaning that the processing of the microprocessor can be done much faster. All right, so the Intel Pentium is from 1992. Okay, now it is just can be copyrighted because the copyright law, you can only copyright the word. Alright, you cannot copyright the number. Okay, that's why the Pentium have the copyright, not 8080 version of the microprocessor. Okay, so initially the Pentium has speed of 60 and 66 megahertz. Alright, so the designers utilize over 3 million transistors on the Pentium chip. Okay, so how that can be done by using the sub-micron fabrication technology. So the transistor during that time was in the size micrometer. Okay, so the size is in 10 to the minus 6 meter. So it is very small. Alright, so the new design features is made the speed twice that of 8046, 8486 and 66. Okay, so as was mentioned, it is 3 times faster than the original 8088. Okay, so it is fully compatible with the previous x86 processor, but includes several new features. The separate 8K cache memory is available for coding and data. Okay, so it has the capability of 64-bit bus. All right, so it was improved. Okay, from the previously we only have about 20 bit. Okay, from 8086. So the Pentium is packaged in 273 pins, the PGA chip. Okay, so it is using the BI-CMOS technology combined with the speed of bipolar transistor with power efficiency of CMOS technology. Okay, meaning that the speed is increased, but the power utilized by the CMOS, BI-CMOS technology, it is as similar as CMOS, which does not utilize much power. Okay, and then for the 64-bit, the data bus, it has also the 32-bit registers and also the 32-bit address bus. Okay, so meaning that the location searching can be done in the 32, right? And then it is capable of 4 gigabyte of memory. Okay, and then the next version of the Pentium is the Pentium Pro. It was released in 95. It is the 6th generation of x86 processor. Okay, it contains 5.5 million transistors. Okay, it is designed for server, all right, 32-bit server and workstation. Okay, this is what I just mentioned. After that Pentium, so we have Pentium Pro, and then we have Pentium 2, 3, 4, and Titanium is the one that we use for the server. Okay, so it was introduced in sequence, okay, from 1997 up to 2002. All right, and you can see that tremendous increase of the number of transistor. So let's say in the Titanium, it is actually about 5 times transistors is used compared to the one in the Pentium 4. Alright, and then the cache size is now up to 6 times bigger, alright, from 512K to 3 megabyte. Okay, the physical memory is still similar, and virtual memory is also still similar. And then there is increment in the internal data bus up to 64, the external data bus up to 64, and also there is increment in terms of address bus. Okay, and the data type, so we can consider in terms of, because either up to 64, either in 8-bit, 16-bit, 32-bit, or 64-bit. Okay, so for the normal user processor, Intel produced the Pentium 2 processor in the 97. Okay, so the processor have the feature of MMX technology. MMX stands for the multimedia extension. Okay, so it is for improving the graphics and for the audio processing. Okay, and the Xeon processor, which is still used until today, is released. Okay, the name of Xeon is still there on the server computation, right? So it was released in 1998. The Intel Celeron was also released in the 1999. Okay, it is maybe the processing capability is a little bit limited, but it is used to produce for lower cost processor. Okay. In 99 also Intel released Pentium 3. Okay. And then it has 70 new instructions. Okay. So which is used to enhance video and audio performance and the 3D imaging and the streaming audio. Okay, and then the Pentium 3 version of the Xeon is also introduced in 1999. Okay, and the Pentium 4, okay, is introduced in 99. Okay, so the speeds was varied from 1.4 to 1.5 gigahertz. Okay, and the system bus operates at 400 megahertz. So it is a new architecture based on the 32-bit architecture. Before this, it is a 16-bit architecture. Okay, so it is called a net burst. Okay, it's designed for heavy multimedia processing, okay, video and music and graphic file manipulation on the internet. Okay, so new cache and pipelining technology is also introduced to expand the multimedia instruction set and make the Pentium 4 a high-end media processing microprocessor. So you can look here that the graphics, I mean the sound, the video, so all of that are the multimedia content. So to process the multimedia content, okay, so because it is involve many moving parts, let's say you are doing the graphics, of course you want to make it very clear. So up to now we have the 4K technology. Okay, so we have the 4K technology, and so we want to make it as sharp as possible. So that's why it needs a very huge computing power. Okay, and then it needs a new instructions to be put on the CPU. All right, so usually it is put on the ROM. Okay, so as you can see, when the evolution of microprocessor is actually designed towards to cater the needs on the multimedia content. Okay, so that's why let's say for a graphic designer, they need to use a very high computing technology. All right, so whenever it's involved graphics, let's say AutoCAD, you are using it for designing the this architect is using that for designing the building, for example. All right, but for the other purpose, you don't need as high as possible the computing power. So for example, but if you want to surf the internet, but the content inside the internet involve many graphics and so on, you still need to have a good computer, but not too heavy, because the computing was actually done on the server side where the resource is located. Okay, so that's why if you browse on the browser, you don't need so much of the computing power. Rather than if you store yourself the application for the graphics inside your computer and then you need to run it by yourself, then you need to have a high computing power. So Intel also has selected Titanium as the new brand name as for the first product in the 64-bit family of processor. Okay, so it was formerly called as Merced. Okay, so the evolution of microprocessor is increasingly influenced by the evolution of the internet. Okay, so the Titanium architecture is designed to meet the internet-driven needs for the server and high-performance workstation. Because when there is internet burst, so the servers need to be upgraded. So to give you to serve for the content, let's say for the YouTube, okay, to store the YouTube content, of course, it needs to have a very high, very high-end server, okay, because YouTube consists of many, what we call many high-resolution videos and also many graphics, okay, especially in the content of the video, okay. Alright, so that's why whenever it involves the video processing, the cost will increase. Okay, and whenever there are also many instructions need to be constructed by the processor, it needs to have a large ROM, okay, to ensure that the instructions inside that is big enough, okay, to cover all of the main instructions to be processed by the microprocessor. Okay, so that's the history on the Intel 64 architecture.
Doctor,
Yes.
is it NVIDIA is a part of microprocessor or what? NVIDIA for graphic card.
Okay. Yes, NVIDIA is part of the microprocessor, and it is especially is designed for the graphic processing. Okay, because for the general microprocessor is designed for the computation, normal computation for the computer. So basically that's actually because the normal computer cannot be during that time is not capable of what we call making a very high computation power for the graphics. So NVIDIA focus on making a microprocessor chip, okay, making a microprocessor chip for processing the graphics. Okay, so that's why NVIDIA, as you can see, NVIDIA also have its own PC right now, where the price is, I think, about 100K US dollar. Okay, you can look that for the NVIDIA version of the PC, because it is primarily designed for to cater the needs for the graphics. Okay, so my answer is yes, it is part of the microprocessor for the NVIDIA processing technology as well. Okay, but it is focused for the graphics. But for the microprocessor, the general microprocessor is used for the general use. Okay, it is not specific only on the graphics. Okay, so there are two ways to make the CPU process the information faster. It increase the working frequency using technology available with cost consideration. Of course, when you are doing the manufacturing, so you need to consider the cost, that the cost is capable for the normal user to purchase that technology. If you make the cost very high and the user cannot purchase it, of course, you won't be making any profit. from the product that you produce. So, but at the same time, you want to make it as high end as possible. So you need to consider that. So the company needs to consider that. Okay. So the way it is first for the CPU process the information faster, you need to increase the working frequency of the CPU. So frequency is related to the clock speed, meaning that you need to have a very high clock speed so it can run many information at very short time. Okay, let's say for the 3 gigahertz, all right? So because frequency is 1 over t, right? So for 3 gigahertz, so you have okay up to 3.3 t 10 to minus 13 second. Okay, so at 3.33 10 to minus 13 second, one information already processed. So it is much more less on the for 1 second. So if you look here, so how many information can be processed at 1 second? Okay. How many information can be processed at 1 second? So you multiply that back with the with 60. Okay, so you get the number of data that can be processed for 1 second. Okay, so all right, so actually let me look here. Okay, so it is okay. When I do the calculation, so I get 3 times 10 to the power to the 12. So mean that it is back to 3 gigahertz of information can be processed at 3 gigabyte. Okay, 3 gigabyte of data can be processed for the microprocessor in 1 second. Okay, so that's how the speed actually affect your computing performance. All right, so we have another way by changing the internal architecture of the CPU. All right, so the CPU as the layout, as you can see that it has you can design it in the multiple types. Let's say you place the ALU over here, and then you have the shift register over there, and then you also have the register over here. But you can also redesign back the microprocessor. Okay, for example, over here. So we have the 8088 CPU over here. You can see that the ALU over here, and then you have the bus interface unit over there. Okay, so by changing the internal architecture, we can also increase the processor computing speed. Okay, so this is an example for 8086 or 86 CPU. Okay, and we are also Intel also introduced the pipe aligning technology. Okay, which in the processor of 8085, which it could fetch or execute at any given time. Right. So the idea of pipe aligning is in simplest form is to allow the CPU to fetch and execute at the same time. Okay, so you can consider, okay, so the pipeline, okay, so for example this all right, so this example of 8085 processor, so fetch execute what I just mentioned to you. All right, I just mentioned to you the working of the processor. So you need to fetch first, retrieve the information from the memory, and after that bring back that to the register, and then do the execution once the information is decoded. All right, but for the pipelining technology, so it is arranged in the pipeline. All right, So one pipeline, second pipeline, third pipeline, and fourth pipeline. So you can actually, because it increase, okay, for the time taken from patch 1 to execution number 2, for the pipeline technology, it can do the patch 1 up to execution number 3 at the same time with the non-pipeline technology. Okay, so it has how to do that. It do the patching, the second patching during the execution of the first we call the first instruction. Okay, so because you may because you see that the address bus is not working during the execution, right? So that's how Intel um, actually take advantage of that. So do the patching and then finish, do the execution. While during the execution, at the same time, you do the patching of the second instruction, and then the execution of one finish, and then right after that, the execution of second instruction is done, and next the patching number 3 is done, and then the execution number 3 is done, and then the patching number 4 is done, and so on. All right, so it is actually pipelining the execution and also the patching process. That is what is meant by the pipelining. All right. So in the 8086 processor or 8088, so the internal structure is divided into U. First, the execution unit, and next is the bus interface unit. So these two sections work simultaneously. So as you can see here, okay, this is the execution unit. All right, the execution unit, and this is the bus interface unit. Okay, so this unit and this unit works parallelly. Okay, so that is the change of the internal architecture of the CPU. So it can increase the computing processing speed. All right. So the BIU accesses the memory and peripherals while the EU executes instruction previously patched. Okay, and then this works only if the BIU keeps ahead of EU. So the BIU of the 8086 86 has a buffer or queue. Okay. All right, so the BIU needs to make a little bit distance with the EU, so it must always be ahead of EU. If not, then it will be trouble. Okay, and then the microprocessor will confuse, okay, what to be done. Okay, so it must be in the sequence. All right, so once done that, and then do that, and then do another thing, and so on. All right, so the buffer size is 4 bytes long in 8080 and 6 bytes size in the 8086. So the pipelining technology has two stages, fetch and execute. Okay. So in more powerful computers, it can have many stages. All right, if an instruction takes too long to execute, the queue is filled to capacity and the bus will sit idle. Okay, so this is the disadvantage, right, when the instruction is too long, because the bus won't do anything. Okay, because the bus is just like highway, so it's like the empty highway without the cars on the highway. Okay, the bus actually should be busy in order to ensure that the computing can be done at high speed. Okay. All right. In some circumstances, the microprocessor must flush out the queue. Okay, as we said, we have the buffer technology, so like BIU needs to be ahead of the EU, so as a buffer, but at some time it need to jump, all right, it need to jump, some instruction needs to jump because it is slow, all right, so some other information needs to be executed first. Okay, so when it is that, so the BIU starts to fetch information from the new location in the memory, and information fetched previously is discarded. Okay, so meaning that it can jump, so the previously because it's too slow, then you can actually discard that, and then you can start with a new fresh fetching from the memory and do the next execution. Okay, so the as usual, so BIU needs to be ahead of EU, all right, as I said, before it do the next execution. So this is called a branch penalty. Okay, so in a pipeline CPU, the too much jumping around reduces the efficiency of the program. Okay, of course, when there's too much jump, so the instruction hasn't yet finished, and then you discard that, all right, and then you do the next session. Of course, it will reduce the efficiency of the program. Okay, so right, I stop here for today. So we will continue again on next Tuesday. So that was about the pipeline technology. Okay. All right. So you have the slide, right? So you can actually go browse through the slides and then read on your own. Okay, and then lastly, so the attendance before we dismiss. So could you guys please turn on your camera? Okay. All right, I will count from 10. Okay, everyone is ready? Okay. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, cheers. Hold on, give me another second. Okay, give me one more shot. Okay, thank you everyone. So you have any question?
No, Doctor.
Yes, Doctor.
Okay. All right. So thank you for the class today. So I see you again on next Tuesday. All right. So any information I will give on the WhatsApp. So maybe after this you have the assignments for the course. Okay. I'm still working on that. So I will give you the information later on the WhatsApp. All right. So that's it for today. Okay, Assalamualaikum and bye-bye.
Thank you, Doctor.
Thank you,
Waalaikumsalam,
Doctor.
Doctor. Thank you,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay, welcome.